come up in a bit. Okay. We are recording. For some reason, went back to that. It's got the slideshow set up for where we're going to start today. But I wanted to make this announcement because I wanted everybody to be able to hear it. Over the weekend, finally I carved out a little bit of time that I got your syllabus updated, and it's on Blackboard. The research paper instructions updated, they're on Blackboard. My locator card updated, it's on Blackboard. Now, I did not get the PowerPoints done because I didn't have the DVD at home with me. It was here at the office, and I was home, and I tried to copy them over last fall's, but they just wouldn't do right. So I'll try to get that done. If not today, possibly tomorrow afternoon or Thursday, but try to get it done before Friday, okay? Try my best to get those done. All right. Now, in addition to that, I created a new playlist for Math 112, and I loaded onto that playlist the first two classes. So if you weren't here for either of those two classes, you can now go to Blackboard under Content, which is when you get to the home page of this class. When you get to the upper left corner, you have a home page, something, and then somewhere down there in the top few things is a tab called Content. If you click on that, then you'll see all the content I put out there. The syllabus, the research paper instruction, the locator card, and later you'll see the PowerPoints. They're not there yet. Also, I put there some sites that either I found or students have told me help them. Education Portal, MathVids, Prof. Rob Bob. I mean, there's just several that are out there. For some reason, no one's given me Khan Academy yet, but I know they have good stuff too. So you can find some aids there. And then the very last one says Math 112 YouTube videos. That's ours, okay? Click on that. You'll open the playlist, and then the first class, second class are there. I was trying to use the one I did last term, and I could not get the playlist title to change, so I've got to figure out what to do with that. What I think I'll do, if I can, is bring in some of those too, so if you want to look ahead a little bit, you can do that as well. The videos we've done in the past course. If I can't get it done, it'll just be the ones for this course. All right. I think that's all. Any questions on anything we've done so far, what we're about, anything else? So therefore, if you check that syllabus, read through it. If you have any questions, ask me. If not, either print out or email me that last page saying you've acknowledged that you've seen it and understand it, and I've explained it to you. If you weren't here that first day, the first video is entitled Syllabus, and that's pretty much most of what we did that day. Okay? Second video was entitled Research, but we actually got started on 1.4. All right, any questions then? Okay, I think this is where we left off last time. It's on page 36. If you got your text, just under the 4 ways to represent a function, that's what we talked about at the end last time. So, and also let me apologize for my voice. I went to a basketball game Saturday night and yelled too much. Sorry. Okay, to determine whether a relation is a function, you must decide whether each input value is matched with how many? Exactly one output value. If you have an input value with 2 outputs, different outputs, not a function, okay? But if each input does have an output, one and only one output, then it's a function. When any input value is matched by two or more output values, the relation is not a function. And I think that leads to example 1. Okay, determine whether each of these represents y as a function of x. Okay? The first is stated in a sentence. Remember when we talked about different ways to express a function, one of them was verbally. Here is a statement. The input value x is the number of representatives from a state in the U.S. Congress. The output value y is the number of senators from that state in the U.S. Congress. Okay? Is that a function or not? Okay, I hear some notes. Why not?
There's two inputs. There are two inputs of the same.
Say it better one more time.
Two inputs of the same.
Two of the inputs may be the same. Well, that's fine as long as the outputs are the same too, are they? Okay. Give me an example of one where X is the number of representatives from a state, and it has one output for one X and a different output for the same X.
211 and 210.
Say that again.
211 and 210.
Oh, no. This is B. This is A. This is A. Just a statement. Don't look here. Okay. Yeah. Is that a function? Second. Yes, it is. And why is that? No matter what state you're from. Wyoming, I think, is the least populous state in the U.S. Okay, it has one representative. How many senators does it have? 2. Okay? Now, California is the most populous state in the U.S. Can I get your name, please? Yolanda. Okay, this is your first time here, right? All right, welcome to the class. Say again. Oh, you've been trying to find. Okay, we move around a lot. No, I'm just kidding. We'll be here. Let me catch you up then on how you can catch up. I record every class that we do using a program called Screencast-O-Matic. Now, previously we used something called Tegrity that as soon as I finished the class, I ended it and it started uploading to Blackboard. This one doesn't work this way. This one uploads to YouTube, and then I have to place it in a playlist later, but it takes a long time to upload. Tegrity uploaded usually in 10 to 15 minutes. This takes hours, okay? Not as good a program, but it's cheaper. Guess what one? Never mind, I won't go there. Okay, so how do you access that? Are you familiar with Blackboard? I am. Okay. In Blackboard, when you go to this course, in Blackboard, the home page, you'll notice there's a series of tabs in the upper left corner. There's home page, there's something else, and then somewhere down the line there's something called content. You go to the content tab there on that home page, the main page, then you'll open up and all the content that I put there is there. Number 1, you'll see the syllabus. Number 2, you'll see research paper instructions. Number 3, you'll see my locator card. When I'm in class, when I'm not in class, when I have office hours, when I don't, when I'm on campus, off campus, that kind of stuff. Now, later, I don't have them there yet, the PowerPoints will be there. I didn't have my DVD at home with me this weekend, so I couldn't load those. But then I put out there some sites that either I found or students have given me they found were useful for this course. One's called Education Portal, one's called Prof. Rob Bob, one's called MathVids. Seems like there's another one. Slater, I think it is. Okay, so there's several sites out there that you might or might not find useful, but if you need them, use them. And then there's the very last one, says MTH112 YouTube videos. If you click on that one, then you'll see 2 files there now. Maybe by the time you click on it, it'll be 3, okay, or something. But the first one that we did last Tuesday says syllabus, and that's most of what we talked about in that class. Second one says research. We started with the research paper, but then we picked up in 1.4. Okay? So not only do you have the syllabus in content as a static form, but you also have it on the YouTube video when I talked about it. And the YouTube, the Screencast-O-Matic records everything I say and everything that's projected on the board in sync, so it's almost like you were here. Not quite, you can't ask questions in the video, but they're there. And here's Jared. Now, I'm not going through this again with him because he was in my class last term. So you know about Screencast-O-Matic, the videos on, yeah, okay. So you can go back and review everything we did. And when you read through, the syllabus and the research paper instructions, I had some updates to do. So when you see those and hear me talk about them, you'll hear me talking about the corrections to be made. But the one that's actually out there, the corrections have been made. The other thing I talked about on the second day, Thursday, was safety. And you'll hear all that too, so please listen to that. All right, we're just talking about functions. We're talking about the A one here. The input value X is the number of representatives in a state. The output value Y is the number of senators. To be a function, for any input, you can only have one output. Okay? And we were saying, is that a function? And I think the consensus was that people are still coming in. Okay. Can I get your name, please?
Justin.
Yeah, Justin. Got it. My hearing's bad, folks. My voice isn't good either, but I went to a basketball game and felt too loud. Sorry. Okay. So far we have said, yeah, we think this is a function. Because no matter what input you've got, one, like for Wyoming, or I don't even know how many congressmen California has. How many does Alabama have? 8 or 9? 7? Second? 7. Okay. Yeah. 7. Okay. We have 7 representatives. How many senators do we have? 2. California may have 100 some odd representatives. How many senators does it have? 2. So for any input X, from 1 to 100 and some odd, the only output you get for any of them is 2. That's what we call a constant function. It never varies. There won't be any one X that has more than one Y because there's only one Y. Okay. That's not the only time, but that one for here. Okay, B. Jonathan already answered because he thought that was part of the first one. Is this a function? This time we've represented the function as a table, which is also corresponding to ordered pairs, X, Y. Is that a function? No, why not? Yes, if you give me a 2, it spit out an 11, but the next time you gave it a 2, it only gave you 10. Not a function. For any given input, there can only be one output. Okay? The rest of those would fit. These two knock it out. So if you ever see the same input twice, the only way it could be a function if those outputs are the same. You just repeated it. But if those outputs are different from the same input, not a function.
So it would have to be 11.
What's that?
It would have to be 11.
Well, which one or the other. We don't know which. But if it's both of them, not a function. Okay, how about C? This is a graphical representation of a function. What's your input here? The horizontal values that go into this. And what are they? Negative 1. 1. 0. Negative 2. 2. Y'all count funny. No, okay, yeah, that's perfectly fine. Doesn't matter the order. Okay, what's your output values? 3. 0.
2.
Negative 1. Is that a function? Why? For any one input, you only have one output. Okay, only one output. Now, if this one had an output up here too, not a function. That would be like repeating here, same input, two outputs. Can't happen. That is a function. Now, this one, and that one are all examples, and this is going beyond what the book does, of what we call discrete functions. Okay? If you took a line here and drew a parabola through here, that would be a continuous function. That means every point on that line would be a value. Every pixel would be a value. And in between the pixels would be a value. That would be a continuous function. This is discrete because those are individual points with nothing in between. Okay. That's beyond what we're doing now, but it is an example. Okay. Well, here's their, you answered it well. Let's see how they did. Verbal description does describe y as a function of x for the A one, regardless of x, 1 to 100 and some odd, the value of y is always 2. Those are called constant functions. Okay? Only one output for any value. Number of representatives is 2. Okay? The table did not describe a function because the input value 2 is met through two different output values, not a function. Okay? And the graph does describe a function because every input value, -2, -1, 0, 1, and 2, had one and only one point that corresponded to that. Okay. Now let's step back. I'm going to jump a little ahead on you. Whoops. Here's another thing you can use for graphical representation. I don't think we've done it yet. It's called the vertical line test. If you draw a vertical line anywhere on this graph, it can only be intersected by a point no more than once. Well, all these vertical lines don't get intersected at all. That's okay. That one gets intersected once. That one gets intersected once. The y-axis gets intersected. So you see, vertical lines through a graph is another way to tell whether, because a vertical line represents one input value, and if it's intercepted only once, no more than once, then that is a function. We'll get there later. We usually use that for continuous functions more than discrete functions. Okay. This is top of page 37 now. Representing functions by sets of ordered pairs is common, and this is what I was saying before, in discrete mathematics, when you can list them all. Sometimes it may be an awful lot, but you may not be able to list them all, but you can list the vast majority of them. Okay. In algebra, however, it's more common to represent functions by equations or formula involving two variables, and generally this will produce continuous functions. Here's one. Y is equal to x squared. Okay? Give me an x. Any old x. 2. What would the y corresponding to that be? 4, because when you square 2, you get 4. Do you get any other numbers other than 4? No, only one answer. That's a function. Okay? Give me another x. 3, what do you get as a y? 9, very good. Give me another x. 5, what would you get? 25. Y'all don't like negative numbers, do you? Give me a negative x. -1, what do you get? Second? +1. Give me a 1, what do you get? +1. Hey! Now I had 2 x's gave me the same y. Does that violate anything? No. It's that 1x cannot give you 2 y's. That would violate it being a function. Okay, so we call them y is a function of x. This represents the value y as a function of the value x. In other words, what's the function here? It's the squaring function. It takes the input, x. What's the set of all input values? Called domain. It takes any value out of the domain, squares it, and that gives you the output value. So that's the squaring function. In this equation, we say x is the independent value. You get to choose it. Any x you wanted to. But once you've chosen it, it fixes the y, right? So therefore, y depends on x. The y depends on what value you put in for x. So it's called the dependent value. Now let's go back to our graph. Where do we usually plot the x's? On the horizontal axis, and the y's on the vertical axis. So I know everybody calls this the x-axis and the y-axis. Guess what? It's not always x and y, but it's always horizontal and vertical, and it's always independent, dependent. Remember that, okay? Now, any questions? Okay. Now, the domain of a function is the set of all the values. We've hit it 2 or 3 times. You know what? When the book mentions something several times in different ways, that may be important. So hang on to these. The domain of a function is a set of all the values taken on by the independent variable, the input variable, x. The range of the function is the set of all the values taken on by the dependent variable, y. Now, I meant to say this before. Let's go back to, oops, there it was. Okay, this one. Here's one way I think of domains, input variables, input values, and those kinds of things. Imagine you had a very, very bright light sitting up here. You shine that light through the function here, and imagine your screen is at the bottom. Every place you see a shadow, which would be represented by that represents the input, the domain. You see one at -2, at -1, at 0, at 1, and at 2. The independent, the horizontal values, the x values. If you had your light way to the left or way to the right, doesn't matter which, you could have the light underneath shining up, doesn't matter. But if you have it left or right and shine it that way, then the values that are in the shadow would be your range from -1, 0, and 3. Okay? So that's the other way to think of it if it helps you in domain and range when you have graphical representation. Okay. Got it? The ranges of the functions, a set of all values taken on by the dependent variable y. Otherwise, shine the light left or right and see where the shadows are. Okay. Now, they skip some of the examples, and I don't know why, because this is a pretty important example. The others were pretty easy. This one really gets down to it. And by the way, time out again. On page 37, there is a very handsome character there. Okay. This is Alexis and Allison, but I don't know which is which. Allison, Alexis, okay. All right, I'll probably never know for sure, but anyway, thanks for telling me. Okay. And guess what, folks? Of the people who have been to class, and I think it's just about everybody now, we have perfect attendance. Way to go. Keep it up every day. Fantastic. Okay. All right. We're on page 37, example 2. Oh, I was just going to say, on page 37, upper left corner, a fantastic picture of a very handsome character, Leonard Euler. Okay? Mathematicians have to be ugly, by the way. No, I'm just kidding. Okay. Boy. Wow. Okay. But he was a Swiss mathematician, one of the most prolific and productive mathematicians in history. Okay? He's the one that gave us the function notation, y is equal to f of x, and many other things. For instance, I don't know if any of you are familiar with the value e. That's the root of the natural number system. Okay? It's not 10. Our real root of our system is an irrational number e, 2.7, blah, 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 blah. Okay? We'll get to that later. Okay? Guess why it was named E? Leonard Euler was the one who discovered and perfected and found out all of its principles. Okay? I can't remember now. It seems like he published hundreds, if not thousands, of papers, many of them groundbreaking. There are several formulas out there called Euler's formulas, or Euler's method, or Euler this and Euler that. And his name is spelled E-U-L-E-R, but it's pronounced like it's the Eastern Oilers, but they don't exist anymore. Okay, Euler. He would be a good paper topic, or the number E. I mean, anything to do with him, you could find tons of stuff out there. If you're interested, he's a possibility. Okay, so let's do example 2, page 37. Which of the equations represents a y as a function of x? Let me get my pen activated. Okay, unfortunately, the way this comes up, I can't activate my pen using the black because then I would turn off Screencast-O-Matic. So I have to use dark purple. So forgive me, but it's the best I can do here. Okay. X squared plus y is equal to 1. Now what the problem says, does this equation represent y as a function of x? Doesn't look like it in this form. What would you have to do to get it in the form to give you a better idea? Say again? Okay. I think I heard you saying, but my hearing's bad, solve for y. That's what you were saying, right? I thought so, okay? Let's solve for y, isolate the y, get everything else on the other side of the equation. So how would you do that? Subtract x squared from both sides. Is that what I heard? Okay. So that would give 0 there. Y is equal to 1 minus x squared. Does that look like we have y as a function of x? Yes, it does. Give me an x, any x in the world. I evaluate it, square it, subtract it from 1. That's going to be my y value. 1 and only one y value. Yes, that defines a function. How about this one? It looks almost the same, doesn't it? Minus x plus y squared is equal to 1. Does that equation represent y as a function of x? What would we have to do? Isolate the y. Solve for y. What's the first thing you would do? Add x to both sides, and that gives us y squared equal 1 plus x. Okay? Then what? That still gives me y squared. I want y. Take the square root of both sides. Square root of this gives you y. Why not? Okay? And the square root of this gives you not quite. Plus or minus the square root of 1 plus x. Remember when you take square roots, what's the square root of 4? Say again? It's not just 2, it could be minus 2. Anytime you take the square root, you have to precede that with plus or minus. Okay? Now, is that a function? Okay? Give me an x. Real easy x. Very simple x. Simpler. 0. I like it. Okay. All right. 1 plus 0 is? Square root of 1 is? Or? Negative 1. You gave me 1x, 0. You gave me 2 y's, plus 1 or negative 1. You could have done it with 1 here. It would have been plus or minus square root of 2. Or with 2, yeah. But every x you give me is going to have 2 possible answers. Except for negative 2. Give you no answers at all. Well, that doesn't keep it from being a function, but it just means you have to limit the domain. But the fact that you get 2 outputs for every 1 input means it's not a function. Now, if you were to graph that, does anyone know how it looks? It basically, this isn't exact, but it looks something like this. And guess what? Vertical line test crosses more than once. Not a function. For any given x, there's sometimes 2 y's. Not a function. Okay. Now, I mentioned to you before, I'll say it again now, I'll probably say it a few times, but since everybody's here now, you've heard it once. After every example in the text, there usually comes a checkpoint, which is problems very similar to the ones we just did. I wish we had time to do the checkpoints in class 2. We just don't have time for them. So what I suggest, when you leave the class, if you're going to another class, fine. Whenever you have some time, the first opportunity you have, go back and do the checkpoints for the same problems we did in class. Because while it's fresh on your mind, repeat them. That's how you learn it best. Okay? If you don't have any chance until you get home, do the checkpoints when you get home. And that'll help you doing your homework too. Okay? And if you forget what we did in class for the example, it's on Screencast-O-Matic. Go to the YouTube video. If it's loaded yet, you can check on that. All right. Any questions on that? All right. When using an equation to represent a function, it is convenient to name the function for easy reference. And we usually don't name it Fred and Sally and Sue. We name it something else. For example, you'll know that y is equal to 1 minus x squared. That was the first A example we just did. Describes y as a function of x. Suppose that you give this function a name. Now, if I say, give me a variable. Say again? G. Boy, he's different, isn't he? Okay? Just about half the time people say X, because that's everybody's favorite variable, it seems like. Well, guess what everybody's favorite function name is? F. It is Y, which is something important, but it's function F. Suppose you give the function the name F. And you'll find in the book there's more F of something than any other function name. But it could be G, it could be R, it could be Y, it could be just about anything. But the most popular one is F, just like the most popular variable is X. Okay? So if your input is your X, okay, your output is the f of X. But what do we call f of X here? Y. Okay? Now, if you remember this, you're going to have you'll be halfway, maybe 3/4 of the way to understanding functions. If you remember y is equal to f of X, they are the same. If you remember that concept, then that's going to help you enormously. Okay? And Leonard Euler was the one who came up with this notation, y is equal to f of X. Rather than call it y, we call it some function of X. Okay? Now, the symbol f of X is read. The value of f at X, if you want to say a lot of words, or we just say f of X. Okay. Now, they're going to get to this later, but I'm going to say it now. If this were some other variable, pick another variable. Second? R? I. Okay? If this were I, X, or if this was a number, give me a number here. Any number. 2, give me a number for X. 1. If you had 2 parentheses 1, what would you do with that? You would multiply. But if you have a symbol of something, parentheses there, then you assume that means function, not multiply. F is not a variable. It's a function. F of X means the function that you're going to operate with, like the squaring function or whatever function it is, this is your input for that function. So the symbol f of x corresponds to the y value. Again, if you remember this, you got most of the functions not. Y is equal to f of x. Okay? So you can write it that. Keep in mind, f is the name of the function, Fred or Sue or Sally or something like that, whereas f of x is the value of the function y at the value x. Okay? For instance, f of x is equal to 3 minus 2x. Okay? That is the function. You take the input, x, multiply minus 2 by it, and add that to 3. Or multiply 2 by it and subtract that from 3. That's what the function does. That's what the sausage grinder does. It does those things. And it spits out a y value. So, what would be the value represented by f of negative 1? How would we do that? You plug it in, just like Blade, right? Everywhere you see an x here, you put a negative 1. So if you put a negative 1 for x here, put a negative 1 here. What's negative 2 times negative 1? Positive 2, 3 plus 2 is 5. So f of negative 1 is 5. If you have f of x, you expect to see an x over here. You have f of a number, you expect to have numbers over there at the end. What's f of 0? Okay? 3, because you plug a 0 here, negative 2 times 0 is 0, you would have f of 0 is 3. The y value, when x is negative 1, the corresponding f value or y value would be 5. When x is 0, your y or your f of 0 is 3. What's f of 2? Negative 1. Y'all are good, really good. Okay? So to find these values, substitute the specified input value where you see the x over there. Okay. Now they're going to get a little tricky on you. Okay? And this shows what we just did. 5, 3, negative 1. Y'all already did it. Okay? All those f is often used as a convenient function name, and x is often used as an independent variable. They're not the only ones on the farm, you know. You can use other letters. Okay? F of x equal x squared minus 4x plus 7. That's the function. Takes whatever you put into it, squares it, subtracts 4 times it, and adds 7 to it. That's your function. Okay? Now, you could have said that was f of t is equal to t squared minus 4t plus 7. Whatever you put in, it doesn't matter. It's the same function, even though it had a different variable. But guess what? G of s is s squared minus 4s plus 7. Same function. You change the input, you change the function name, but it's the same function. It takes what you put in, squares it, subtracts 4 times it, adds 7 to it. It's the same function. They all define the same function. In fact, the role of that independent variable that sounds, oh, we're independent, it's just a dummy variable. It's a placeholder. It represents any number you want it to do. So you can change the variable name, you can change the function name. As long as you're doing the same operations, it's the same function. Okay. Now, not only that, you don't even have to have numbers in there or variables. You can have gray rectangles in there, okay? F of the gray rectangle is the gray rectangle squared minus 4 times the gray rectangle plus 7. You could have a stick man. You could have anything in there you wanted to. You do the same. The function tells you what to do with whatever's inside. A function defined by 2 or more equations, boy, this aggravates me. They should have a new slide here. They didn't want to do a new slide. This is a new topic, okay? Let's do example 3 before we go to the new topic. And I don't think they have example 3. So let's do it at the bottom of this. Okay? Let g of x equal to minus x squared plus 4x plus 1. Okay? Then you find each of the following function values. What is g of 2? How would you do that? Yeah, everywhere you see a 2, plug an x up here, plug in a 2. So this would be negative 2 squared plus 4 times 2 plus 1. Now we have a little dilemma, don't we? What is this? Okay. Remember our rules of order of operation? Please excuse my dear Aunt Sally. I don't know what she did, but please excuse her, right? Okay. What does the P stand for? Parentheses. We don't have any parentheses here. I'll put one in there, but it's not. Okay. So we're through with that. Then what? E is for exponents. You do the exponentiation first. Then you do, my dear, multiplication or division. And then you do addition, subtraction. This comes last. You exponentiate first. 2 squared is 4. Then you negate. That would be a negative 4. Now, yes, really. Rule of like. Say again? Yeah. If you put the negative 2 in parentheses, then you do the parentheses first. You link that negative with the 2. Then you square that. That would be positive 4. But the negative on the outside with no parentheses, exponentiate before you subtract. You change the sign and say subtract. So this would be what? Negative 4 plus 8 plus 1. What would that be? 5. Very good. Excellent. Okay. What would this be? G of t. Okay, you go back to this. What would that be? Minus t squared plus 4t plus 1. Whatever was that, your x's up here become t's down here. So the x becomes a t, x becomes a t, everything else is the same. Now getting really weird, okay? What would this be? Yep. G of x plus 2. What would that be? Go back to your original definition. What would that be? A negative, parentheses, x plus 2 squared plus 4 times x plus 2. I put that in parentheses 2 plus 1. Okay, now we've got a little bit of work to do, don't we? What do we do first? Square first. Now, do y'all remember how to square a binomial? Easy way or hard way, either way. How do you do it? Say again? What do you mean by that? Multiply 2 together? Yeah. One way you can do it is this way. Go off to the side and do scratch work. X plus 2 times x plus 2. That's what we mean by squaring something. Multiply it by itself. And how do you do that? FOIL, which is first, x squared, outer plus 2x, inner is plus 2x, last is plus 4. I didn't write my x's in there. What was wrong with me? Okay. Now, not only do you have a smiley face, but you also have your answer when you combine like terms. And what does that become? X squared plus 4x plus 4, because these two are like terms. Okay? So that would be a minus x squared plus 4x plus 4. Now, you can always do that when you're squaring a binomial or a trinomial or anything. Multiply it by itself. But when you're doing a binomial, here's a little bit easier way. Okay? Square the first, twice the product of the second, square the last. Because that's what we did. We squared the first, we squared the last, and we squared the product of the thing. They were the same because it's the same thing, twice the product of the two. So if you want to be a little lazy, and I have this theory about mathematics. I think to be a good mathematician, you have to be a little lazy. Do any of you qualify? No, you're all hard workers. Well, you can still do it, okay? But if you're a little lazy, the reason I say this is mathematicians are always trying to find the easiest way to do a problem, okay? That comes in, being lazy like that comes in good stead. Okay, so we've done the first term. Let's do the next one. What does that give us? Plus 4x plus 8 plus 1. We still got to do our negation there, so let's do that. Help me? Negative x squared. Say again. Minus 4x minus 4 plus 4x plus, I'm going to go on and make that 9. Okay, you don't have to. I'm just lazy. Okay. And here, what do you notice happens here? 4x's add to 0. Yeah, exactly. I don't like to use canceling because it sounds like you're getting rid of them, but you're not. You're adding them. They became 0. So this is minus x squared, and what's the rest of it? Plus 5. There's your answer. There's what g of x plus 2 is. If you have an x in the input, you anticipate having an x in the output. If you have a number in the input, you expect your output to be a number. If you have a variable here, you expect your variable there. Okay. Not always, but you expect that. Pretty important problem. Why did they skip this? They do the easy ones on the slideshow and leave these for you to do. Any questions on that? By the way, there's a checkpoint there. Don't ignore it. Try to do those as soon as you finish, get home, get wherever. Okay, get to the library, get to another classroom. All right, now I think, let me erase this so you can read again. Okay, now we get to this. A function defined by 2 or more equations over a specified domain is called a piecewise defined function. What in the world do we mean by that? Well, here's an example. Here's your f of x. It's defined to be x squared plus 1 for all x's less than 0, but it's x minus 1 for all x's greater than or equal to 0. Okay, that's what this notation means. It's one function. It just has, 2 equations for different parts of the domain. By the way, this covers the entire domain. What's your domain there? All real numbers. All real numbers less than 0, and all real numbers greater than or equal to 0. All real numbers is your domain. But depending on where you are, you determine which of these equations you use. So that's a piecewise defined function. I like to call it, where's Waldo? Okay, where are you? Okay, let's try it. Evaluate this function when x is equal to minus 1, 0, and 1. So let's start with f of minus 1. Where are you, Waldo? Where is minus 1? Is it less than 0 or greater than or equal to 0? Less than 0. So use the top one. Don't use the bottom one. And what would that give you? Negative 1. This time put that in parentheses, squared, plus 1. And what would that be? Yeah, 1 plus 1 is 2. Didn't know you'd be doing such high-level math today, did you? 1 plus 1 is 2. All right, y'all are good. You've done your homework, right? Okay. Let's do f of 0. Where are you, Waldo? Second one, because this is equal to 0. So use this one. That would be 0 minus 1, which is negative 1. Does everybody see that? Because, where were you with 0? Is 0 less than 0? No. Is it greater than or equal to 0? Yes. So you use this one, not that one. Yeah. See, that tells you what portion of the domain you draw from. Only these x's go here. These x's go there. You don't have 2 different answers. because for any x, you only have one equation. Okay? You have two different equations, but it's for different x's. Now let's do 1. F of 1, where are you? The top one? Is 1 less than 0? No, it's greater than 0. So you're on the bottom again. And what would that be? 1 minus 1 equals 0. You got it. Okay, you weren't very far, were you? 0. Do you see how that works? Piecewise defined function. First, figure out what portion of the domain you're in, then use that equation for that portion. Okay? Determine where you are first. Okay. That, I think, was example 4. Let's see. I think I need to erase all this. Everybody got it? Okay. Let's erase it so we can see how they did it. On the first one, for -1, because -1 is less than 0, use the top equation. That's what your F is there. Plug that in, you get -1 squared plus 1 is 2. You're right. For the second one, for x equals 0, it's not less than 0, it's equal to 0, so you use the bottom equation, the second one. F of x is x minus 1, which is 0 minus 1, which is minus 1. And for the third one, x equals 1, that's greater than 0, so again we use the bottom equation. So it's f of x equal x minus 1, so f of 1 is equal to 1 minus 1, which of course is 0. Any questions? All right. Now, by the way, let's see. Yeah, at least one checkpoint there. Okay, now what they're going to do next is go to the domain of a function, which is on page 40. What they skipped completely was the two really important examples on 39. So let's go back and do those. Okay. We'll do example 5, and then we'll do example 6. These are really important ones, and they just skip them all together. Okay. First one. Find all the real values x such that, okay, I'm going to write this out. Find all values x such that f of x is equal to 0. You want to find the values of x, okay? Here's the first one, A. F of x is equal to minus 2x plus 10. We want to find all the values of x, which makes f of x equal 0. So guess what we would do? Set it equal to 0. Here's your f of x. You want it to be 0. This is f of x. You want it to be 0. So set it equal to 0. And now you do what? Solve for x. So what would you do first? Subtract 10 from both sides. And that would give you negative 2x. That adds to 0 is equal to negative 10. Divide by negative 2. And that would give you, that goes to 1, x equal positive 5. Let's see if that's right. If you put a plus 5 in here, you get negative 2 plus 5 is, negative 2 times 5 is, negative 2 times 5, negative 10 plus 10 is 0. Yes, that works. And I'll just give you a hint here. Because this x was to the first power, we call that a linear function. We haven't gotten there yet. Linear functions have one and only one solution, generally. Okay? May not have any, but most of the time do. Okay? Let's do the B one. F of x is equal to x squared minus 5x plus 6. And we want to find all the x's that makes that equal 0. So what's the first thing we're going to do? Set it equal to 0. Okay? Now, going from what I said before, what is f of x? Now I said, remember,
Y.
y, that's your y. Why not? Okay, that is your y. So what you're wanting to do is find what x's give y equals 0, and that's exactly what you're doing there. That's your y, set it equal to 0, solve for x. Now, when you have a linear equation, you start getting rid of the numbers that are confusing it, right? Subtracting, dividing, whatever. What do you do if you've got a quadratic expression? Factor, excellent, okay? And is that factorable? If it's not factorable, you can use the quadratic formula. But we hope this one is. How do we do that? How do we factor a quadratic? Yeah, let's unfoil it is what I call it. Most books don't call it that. In fact, I've never seen a book stupid enough to call it that, but that's what I call it. Unfoil it. Take the first term. It's the only possible factorization for x squared. X times x. We're unfoiling. Okay, now I don't spell it right, so I go to the last term. And I go to the sign of the last term. What is it? Plus. What does that tell you about these two signs? They've got to be the same. Either both pluses or both minus. That's the only way you get a plus there, right? Okay. Now, since the middle term's minus, these had better be both minus. Because otherwise you're not going to get a minus in the middle. So it's got to be a minus and a minus. And, second, 6 and 1. Let's try it. 6 and 1. Foil it and see if you got it right. We unfoil it, let's foil it. X times x, x squared. Fantastic. X times minus 1, minus x, minus 6x is minus 7x. Wrong answer. 3 and 2. Let's try that one. Okay. Let me get my pen back. Let's try that one. Okay. 3 and 2. Let's go back and forth. X times x. X squared. That's good. Negative 2x. And what does that add to? Negative 5x. Plus 6. Yes, that works. Okay. Now, what do we do? Okay. What you have here is a product of two entities. The product of these two entities is 0. What does that tell you about one or both of those entities? Name any two numbers you can that multiply to be 0. At least one of them's got to be a 0. Can you multiply any two numbers not 0 times each other and get a 0? No, you cannot. So this says that either x minus 3 is equal to 0 or x minus 2 is equal to 0. That's the only way you can get a product of 0. So what does the first one give you? Now you got a linear equation, you just add 3 to both sides. And that gives you x equal 3 or x equal 2. Yeah, after a while you don't have to do all the steps. Okay? Let's check and see. Let's plug in a 3 here. What would that give you? 9. Minus 15 would be negative 6 plus 6. 0. Good. How about 2? 4. Minus 10 is? Negative 6 plus 6? 0. And guess what? You got maximum exponent of 2. You expect to have 2 solutions. I'll always have 2 solutions, but you expect to have it. All right. He's come back. Okay. All right. Any questions on that? Either x equal 2 or x equal 8. It said find all the x's with a linear equation. The most you ever have is 1. Quadratics, most you ever have is 2. Okay. Now, neither did they do number 6, example 6, so let's do that one also. This time it says finding values for which f of x equals g of x. Find the values of x for which f of x equal g of x. Okay? And the A part says f of x is equal to x squared plus 1 And the g of x is equal to 3x minus x squared. Okay? Now, what would you do? Okay? Say that one more time. Okay, this is g of x, so instead of g of x, I'm going to write that down. 3x minus x squared instead of my g of x. And guess what? F of x is x squared plus 1. Write that down for f of x. See, you want f of x to be g of x. Here's the f of x equal, and here's g of x. You just write it down just like they tell you to. And now what do we do? Yes, because you've got quadratics, you want to get everything on one side, and what on the other side? 0. Yes, that's how you solve quadratic equations. So which one would you want to move? The negative. So how do we do it? Add x squared to both sides. And since you're coming this way, you have to subtract the 3x from both sides. And what does that give you over here? To the left. 2x squared minus 3x plus 1, and here that went to 0. That goes to 0, so it's equal to 0. That's what you want for quadratics. So now you can factor. You don't want any numbers or any variables on the other side. You can't factor. That doesn't tell you anything. You have to have the 0 there. If this is factorable, we're not sure though, are we? But let's give it a shot. What's the only possible factorization of 2x squared? 2x times x. Very good. Where do we look next? The sign of the last term, and what is it? Plus, which means these two signs have to be the same, and what sign do they better be? Minus and minus. Very good. Now, this is a hard one. What's the only factorization for 1? 1 and 1. Uh-oh. Pretty limited here. Let's see if it works. 2x times x. 2x squared, that works. 2x times minus 1 is minus 2x. Minus x is minus 3x plus 1. Sure enough, it's right. Right? Now what do we do? Set each of them equal to 0. 2x minus 1 equals 0. Add 1 to both sides. And that gives us, I don't have enough room, that'd be 2x is equal to 1, because those go out. And then what? Divide by 2, and that gives you x equal 1/2. So there, oh, can we have fractions as answers? Sure, perfectly good numbers. We love them, don't we? Okay. Over here, what do we do? X minus 1 is equal to 0. Add 1 to both sides, and you get x equal, that's a 1 there, x equal 1. All right. Now, I know y'all want to go back and check this one, don't you? Let's do the 1/2 here. Plugging in a 1/2 here, what do we get? 1/4 plus 1 is 5/4, okay? 1/4 is 1/4. 1 is 4/4. 1/4 plus 4/4 is 5/4. If I had enough quarters, I'd show you that's true, okay? So that's 5/4. Let's do the same thing here. 3 times 1/2 is what? 1.5 or 3/2, right? Minus 1/2 squared is 1/4. So 3/2 minus 1/4, right? 3/2 minus 1/4. What do we have to do? Common denominator, what would it be? 4. How do we get that 2 to become a 4? Multiply it by 2, but if you multiply the denominator by 2, you've got to multiply the numerator by 2, right? What's 2 times 3? Minus 1? 5/4. Yeah, worked out the same. Okay, good deal. The other one's even easier. Okay, let's plug in a 1. 1 squared is? 1 plus 1 is? 2. On this side over here, we got 3 times 1 is? 3 minus 1 is 2, yes, they work. Do we have time? Oh, how sad we don't have time for the B part. So we'll start with the B part next time. Okay? All right, we'll begin there. But we did get far enough along, thank goodness, to give you some homework exercises, right? Yes, okay. So I think I already assigned either 5 or 7. If you haven't done those, do them. This is on page 44, 45, and so on. Do number 9. It has 4 parts, so do that. Do any of the odds 11 through 19. Do any of the odds 21 through 31. Do any of the odds either 33 or 35. And then do any of the odds 37 to 43. And then try either 45 or 47. And we'll stop there and pick up from there. Now, for those who are new, and since everybody's here, I'll say it again. On every exercise set you have, if you notice at the top where it says 1.4 exercises in red, look at what immediately follows. See calcchat.com for tutorial help and worked out solutions for the odd numbered exercises. What did I give you? Odd number exercises. 2 reasons. Number 1, their answers are in the back. If you get the right answer in the back, fantastic, go on. If you don't get the right answer in the back, see if you can figure it out. If you can't figure it out, go to calcchat.com. It's a free website. And there you'll find tutorial help and worked out solutions. Yes? Okay. 5 or 7, 4 or 7, either one or both if you choose. Do number 9, add 4 parts. Do any of the odds 11 through 19. Yeah. Then any of the odds 21 to 31. Then either 33 or 35 or both. Huh? 21 to 31. Odds 21 to 31. Then either 33 or 35 or both. Then 33 or 35 or both if you choose. And then any of the odds 37 to 43. And any of either 45 or 47 or both. 45 or 47. 37 to 43 odds at either 45 or 47. What's that? You choose. Anything that has to do with what we're doing now. By the way, if you look at this, see, in this group, either 5 or 7. In this group, 9. In this group, any of the odds 11 through 19. So you see, you can just look at these and almost pick out what it was. So it'd be psychic. Any of the odds here. Look at this, another paper in. Excellent. Look at that. Fantastic. Way to go. All right. Boy, y'all are good. I got one in my next class, so this is the second paper I'll turn first in this class. Way to go, folks.
How many words?
1 page of text, which means if you start typing here, if you have header and stuff, if you start typing here, go to the bottom of this page, and the second page come down at least that far. That's the page of text. Okay, any format you choose, any font, but use 12 pitch or 12 point. Okay, and say again.
Word count.
Not word count, just on the page. Yeah, on the page, but double space. You get the double space. Okay, and use good, grammar and all that stuff, and also good content. Yeah. Okay. Good deal. And all the instructions are out there. Both you can hear them on the second day of class and there are also blackboard written out
Because
stuff.
I was going to the West Campus and they moved me over here
I see.
because her class was full.
Oh, I thought it's because they liked you a lot and thought you deserved to be over here. I thought that was it. Okay. No, this building, it's hard to figure out room numbers in it. It's so bizarre. I know. But welcome to Bessemer Campus. Okay. We'll get you lost. Okay. Good, thanks. How about you?
Sorry for leaving class.
Pardon me?
I said sorry for leaving class.
Oh.
I got an email from the financial aid lady,
Yeah.
and she told me it probably wouldn't be wise to retake the course.
That what?
I said that it probably wouldn't be wise to retake the course as far as my financial aid goes. She said because it would mess up my cumulative GPA as far as courses attended. I wouldn't get. This would just be considered one course that I attended if I were to retake it. Like, but I would have two different GPAs of like in when they do all the
Okay, before, let me go on and turn off